All right, let me share my screen. There we go, thank you. Okay, I've started sharing my screen. I'm hoping you guys can see it. It's just a whiteboard. Please confirm if it's visible on your side.
It's visible.
Okay, all right, perfect. We are going to get started. So I want to start with some reminders, okay, of the important terminology that they use for this section. Okay, so I'm gonna start with impossible event. Okay. So an example of an impossible event would be when we toss a coin, right? We know we can only get the outcomes a head or a tail, right? Now, if you toss a coin, maybe a 5 rand coin, what is the probability that you're going to get the number 2? That's impossible. You're not going to get the number 2. You can only get heads or tails. Okay, so an impossible event has a probability of 0. Okay. Now, the next one would be an even chance event or even chance event. Even chance. There we go. And that's still visible and legible. So even chance event have a probability of 50%. Right. What could be an even chance event? Coin toss. Remember, I was saying we have either heads or tails. What is the probability that you toss this coin and you're going to get a heads or a tails? It's just 50%. Those are even chance events. Okay. Then, next one, let's talk about certain events now. So certain events have a probability of 100%. What's an example here that I can use? We know that the sun will rise each and every morning. Even if it's cloudy, it doesn't mean that the sun didn't rise. The sun rose, it's just that it's covered by a lot of clouds, but it did rise. So that's a certain event. The probability of it is 100%. The probability of the sun rising tomorrow is definitely 100%. Those are certain events. Okay, now let's talk about mutually exclusive events. This is very important. What do we mean when you say two events are mutually exclusive? We simply mean they cannot happen at the same time. Okay? So, coin toss, you either have a heads or a tails. You cannot get both at the same time. It doesn't work that way. Then we also have a complementary event. So let's look at the coin toss. You either have a heads or a tails. Right. Now, remember that for the heads, you have a 0.5 chance of obtaining heads. You also have a 0.5 chance of getting tails, or 50%, 50%, if you want to use percentages. Now, when you add these two up, right, heads plus tails, that gives you 1 or 100%. Okay, so if these ones give you 100%, then they are complementary to one another. Okay, now also for to be mutually exclusive, they have to be mutually exclusive. Right? What did we say about mutually exclusive? They cannot happen at the same time. Hoping that makes sense. If you have questions, please do post them in the chat. Now, let's look at independent events. So events are independent when the outcome of one event does not affect the probability of the other event occurring. So outcome of one event does not affect the probability of the other event occurring. Okay, maybe let's look at an example. Let's say we have a deck of cards, right? Now, from this deck of cards, we take a card and we replace. Okay, now what would be, so let's say maybe this deck of cards, okay, it's 42 cards, right? Then we take a card and then we replace. What would be the probability of getting any random card after we've taken and replaced? It would still be maybe, so let's say it's the number 6, it will be 6 out of 42 if the card consists of, no, sorry, just fix that. It's not 6, it's 4. It will be 4 out of 42. We're looking at the number 6. So if you take and you replace, it doesn't affect the probability of the next one. So those ones are independent events. And then obviously for dependent, it will affect the probability of the other one. I'm hoping that makes sense. If you have questions, please remember to post them in the chat. Okay. Then now let's look at some important formula there. So for mutually exclusive events, because they cannot happen at the same time, the formula here would be probability of A and B, just fix that. Probability of A and B is equal to 0. Why is it equal to 0? They cannot happen at the same time. All right, now let's look at the complementary events thing. So looking at complementary events, let's look at this example. The probability of not A, right? So the probability of not A A prime would be equal to 1 minus the probability of A. Right? So think about our coin toss. I said we either have heads or tails. Okay, so if this is A and this is B, if we are saying not A, what are we talking about? We're actually talking about B, because we're saying not A. If it's not A, it has to be B. So the probability of not A is equal to 1 minus the probability of A. Let me use a different color to write that for me. So remember that probability of A plus probability of B equal to 1. Okay? Now, if we are saying not A, what do we mean? We mean B. So the probability of B equals to not A. So I'm going to say probability of A plus probability of not A is equal to 1. Then you can take it over, you can take this guy over to the right-hand side so that you have the probability of not A equals to 1 minus the probability of A. That was me just trying to explain that formula a little bit more. Hoping we're still together there. Then there's this one as well. Remember, if you have mutually exclusive events, the addition rule, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Right. Then, if the events A and B are mutually exclusive, and we have P of A and B equal to 0, then this formula can simplify to probability of A or B equals to probability of A plus probability of B. This is then 0. All together. Now you will see it on the formula sheet as probability of A or B equals to probability of A plus probability of B minus probability of A and B. So if you're confusing the two, if you're confusing this and that, a way to remember it is you can say this part here, right? The symbol in between looks like a lowercase n, right? Looks like a lowercase letter n. So the probability of n, right? There's a bit of a similarity there. So if this is n and, then the other one obviously will be or. I'm hoping we're all together there. Okay. Looks like we don't have any questions. Then we're going to carry on. Please confirm there are no questions at the moment, right?
Yes, no questions.
Okay, all right, perfect. Now, let's look at how we would calculate probability. Right? We know that the easiest way to calculate probability, the probability of A is equal to the number of times we can observe A divided by the sample size or the sample space. For example, we roll a 6-sided die, okay? So a die is just a 6-sided figure, right? So dice would be plural, would be 2 or more. If it's just 1, it's just a die, right? It's just a 6-sided figure toy that is used for playing with the numbers 1 to 6, right? How many possible outcomes can we get from this die? We can get a total of 6 outcomes because it's the numbers 1 to 6. It's a fair die. Now, what is the probability of us getting or obtaining the number 3? How many times can we see the 3 here? Remember, we said we have 1, 2, 3, 4, 5, and 6. Okay, here we go. How many times can you see the 3? We can only see it once. Right? But don't make the mistake of writing a 3 here. You can only see it once. The number of times you can see that 3, it's only one time. So that is the probability of finding that, finding the number 3. Okay, hoping we're all together there. Now, let's quickly jump to the fundamental counting principle. Okay, so I'm just going to say, I'm going to call it FCP for short, fundamental counting principle. Let's say we have a certain event A. Pen is misbehaving, just a second. Try to sort it out. Let's say we have a certain event A, and this event can happen in different ways. We don't know the ways, but we know it's in different ways. So event A, that can happen in different ways. And then we have B, which can happen in M different ways. And the number of ways which A and B can happen together, A and B, would simply be N times M. We're all together there. Okay. Let's apply this example here. Let's look at it. So there's John who has 4 shirts, 3 hats, and 2 pairs of shoes. How many outfits can John make? What are we going to use? We're going to use the FCP. We know it will have to be 4 times 3 times 2, which has to give us 24. Hoping we're all together there. If there are no questions, I'm going to move on to some basic permutations. Let's say we want to find out how many ways a team of 11 soccer players can run onto the pitch, right? So the match is about to start and they're going to run to the pitch. We want to see how many ways they can run onto the pitch. All right, so basic permutations. 11 soccer players what's going on here? Okay, let's try this again. How can they run onto the page? Now, this would be the most basic of permutations because all we do is we're going to say 11 factorial. Are we all together there? If we're not together, please remember to use the chat. I want you to understand everything so far because once we get to the questions, they might be a little bit challenging if you are not fully following what we're doing so far. Okay. Then all we do is we know how to find that on our calculators. Just find 11 factorial. It's going to give you a very big number. 399,168,000. Now let's look at a different question. We're going to just change this one around a little bit. We want the probability that the goalkeeper runs first and the striker last. Okay, let me just write it down here in case you want to do it with me. So goalkeeper first. And the striker last. But we want the probability. You want to find the probability that the goalkeeper is going to run first, then the striker will be last. How many players do we have in total? We have 11. So if we put, so I'm going to do this. So GK here, goalkeeper, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the 10th one here, right? So let's just count, including the goalkeeper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we want a striker there. Now here, we don't care about the order. They can run however, they can run onto the field however way. Okay? Then what would that be? 9, 8, the answer 1. So we're going to have 9 factorial in the middle there. For those. And then this is the striker. Let me not say 5, striker. My ace looks like a 5. Now, because we have 9 factorial, to find the probability that the goalkeeper is going to be first and the striker last, we're going to say this is going to be 9 factorial divided by, it's going to be divided by 11 factorial. And that's just calculator work. If you simplify that, you should be getting 1 over 110. Excuse me. Okay. There are no questions. I'm going to carry on. but please make sure that you are not left behind. Let's look at a different question. So we want to create a number plate, right? And this number plate that we want to create, we want to select 2 letters, 2 numbers, and then 2 letters again. So a number plate with, yes, dear.
There's a question from Khunsi there. It says,
Is it in the chat? You can go to the chat.
From TikTok.
Okay, yes, please go ahead.
Why didn't you include the goalkeeper and the striker?
Okay, all right, perfect. So the reason perfect, that's a very good question, right? The reason I didn't include them is my question was specific to say the goalkeeper must be first. And how many ways can the goalkeeper be first? There's only one way. And then how many ways can a striker be last? There's a striker. So it's 1 times 9 factorial times 1. If you want to say factorial as well, that's also fine. We actually have. I'm hoping I've answered them there. So factorial, that is fine. Okay, coming back to this one. So number plate must have 2 letters. Furthermore, it must also have 2 numbers. And 2 letters again. Now we want to find the possible number of plates that we can make, if this is the case. The easiest way to go about such a question is let's just give slots, so empty slots. It's going to be how many? 6 slots, because 2 letters, 2 letters, 2 letters. Right. And then maybe let me clarify that we can repeat. Can definitely repeat. Now, if we can repeat, how many options do we have here? So this is the order that we must follow. How many options do we have for position 1? How many letters of the alphabet do we have? It's going to be 26. Okay. Then next, we also want 26. Now next, numbers. The numbers 0 to 9. That's going to be 10. You're including 0 itself. So 0, 1, 2, all the way until 9. Remember, 10 is just a combination of 1 and 0. We can repeat, so we have 10 again here. Now we want 2 letters again. 26, 26. Then all we do is we multiply. Then don't even stress yourself there. Just rely on the calculator for the answer here. Your answer should give you 45,697,600. I hope I said it right. 45, 6 zeros, that's 1,697,600. 600, not rand, so we're not talking about rand, but 600. Okay, so this means we can make a number, so the maximum number of plates that we can make, if this is what we're going to follow to make number plates, we can only make 45 million of them. That is why now the South African government is planning on changing the number plates because they've ran out of space. They can't make any more unique plates. So it means that they have produced 45,697,600 of them. Hoping we're all together there. Now, let's make it a little bit challenging. Let's say we don't want it to end in the letters GP. Right, so we want to fix the letters. So let's say we still have the positions 1, 2, 3, 4, 5, and 6. So we want a G and we want a P in that fashion. So if we want a G and a P like that, so let's put the G and the P that we are talking about there. Then the rest, what we're going to do is we're going to then fill them in. How many do we have in the first position? 26. The next position is also 26. The next, we have a 10, and we have a 10. There's only one way we can have a G there. There's only one way we can have a P there. Now, if it's only one way, it means I'm dealing with 1 there, and I'm dealing with 1 here. Please make sure that you are with me. Then we just multiply. This would give us 676,000. Yes. So yeah, 67,600. Not 676,000, but 67,600.
Stefan?
Yes, dear?
The Nane from TikTok is asking for you to repeat that.
Okay, all right. Let me finish it up and then go back because I'm not yet done with the question. Then all I need to do is I need to say 45,697,600 minus 67,600. Then I find my answer. Okay, so I'm going to quickly just go back to this question. What we were just trying to do is we wanted to find, right, the probability that this plate that we are creating is not going to end in the letters GP. Okay, now what I said is we have 6 slots. Slot 1, 2, 3, 4, 5, and 6. Let's first put GP. Right. If we put GP there, we're done. How many slots do we now have to fill? It's going to be 4 slots. And in the first position, we still have 2 letters. That's why it's 26. In the second position, we still have 26 because we can repeat. So hence the 26 multiplied by 26. Now the third slot, we have numbers. We need 2 numbers, right? So we need a number in the third slot, and we also need a number in the 4th slot. So hence the 10 times 10, because like I said, we can repeat. Now the 5th slot is where we put the letter G. Because there's only one G in the alphabet, we put it D. Then the 6th, or the last one, is P. And how many P's do we have in the alphabet? Only 1, times 1, times 1. Ones that will end in GP. So this is the ones that will definitely end in GP. So will end in GP. Okay. Now to find the ones that will not, what do? We just subtract these ones that can from the number that we have. the biggest number there, which is 45 million. Okay. Now, our answer there should be 45,630,000. I'm hoping we're all together there.
Tsepa,
Yes, dear.
Tumelo from Zoom is asking for you to repeat that.
Okay. Please pay extra attention. So what we want is a number plate that has 6 digits. Okay, repeating it for the very last time. If you didn't get it, this is your opportunity as well to try and pay extra attention. We have 6 digits. We want our plate to end in the letters GP. We're forced to find it in that order. G there and the P there. It must end like that. Okay. Now, for these ones, position 1, 2, 3, and 4, we are still observing this order. 2 letters, 2 numbers, and 2 letters. So we still can repeat. How many letters can we put here? 26. Then how many letters can we put on position 2? 26 as well. Okay. $26. Where's the stem misbehaving? Just hang on for 1 second. Okay, looks like it's back now. There we go. Yeah, so here we still have 26 as well. 26. There. Now for number 3, that's when the letters, so that's when the numbers are starting. We're done with this. Done with the 2 letters part. Now comes the numbers. How many numbers can we pick from? 10. Now, position 4, we can repeat. How many numbers can we pick from? 10. We want a G in this position. How many ways can we put a G there? Only once. Hence we have a 1B. And we want a P in that position. 1. I'm hoping you're clear now, we do it. Now, all we do is we multiply. If you multiply that, what you're going to get is this number here. And what does that represent? That represents the plates that can end in GP. I'm hoping I'm clear. Now, if these ones can end in GP, how many can't end in GP? All we do is we subtract. We take the 45,697,600 minus the 67,600. Then we get 45,630,000 that won't end in GP. Won't end in GP. Hoping we're clear there. Now, we still haven't found the probability. We want the probability that plate does not end in GP. So probability probability that plate does not end would simply be the plates that won't end in GP, which is what? 45, 613, all over the total number of plates that we can make, which was 45,679. Or 697, not 6, the other way around. 697, 600. I'm hoping that's clear. Then all you do is you just rely on your calculator, and you should be getting 0.9985. If you wrote it as a percentage, that's also fine, 99.85%. That should be clear now. Are there any further questions there, Theo?
No, there's nothing, Sepan.
Okay, thank you so much. I'm going to then carry on before we jump to the past paper questions. Okay, now let's look at this example. So on a spice rack, so on a rack, I think I'm going to switch to my laptop. My iPad is misbehaving. Just bear with me for a second. I'm writing and it's not working out how I want it to work out. Before I stop sharing my screen there, let me see. I can just quickly switch to my laptop. Apologies for that. Technology is just failing us today. Okay, just switching to my laptop. Thank you for your patience, guys. I'm just joining from my laptop. I should be there in a minute. Theo, can you please confirm if you can hear me?
Yes, I can, Sepan.
Theo, can you please make me a host on the other device as well so I can unmute myself?
Okay.
Okay, perfect. Thank you.
Before you proceed there, M from TikTok is asking, when are you doing finance? Please clarify that.
So we've already done finance, and it's on our website, I think. We've done finance last week.
There's a feedback, Tsepang. I don't know if you can mute one of the devices there.
Okay, it should be sorted now. Thank you. Yeah, so we've already done finance, and I think the recording is posted on our website. So please just check our website. We'll send, if you don't have any computer, we'll make sure you. So without further ado, I'm going to carry on. Perfect. This one is working without any problems. So I was saying we're looking at a spice rack. Okay. And the spice rack that we are looking at, what we want to do is we want to arrange spices. So we have 4 green spices, 4 green, 3 blue, and we also have 2 orange.
Hey, Tsepang.
Yes, dear.
Sorry to disturb your flow there. Bonolo is
problem.
asking from TikTok, how do we do counting principles having numbers?
Having numbers.
Yes.
Yeah, the question needs to be a little bit more specific because I'm not too sure I understand what they mean. Maybe there's a question. Maybe they can type that question on TikTok and then send it to you. Then I'll be able to answer because I'm not too sure I understand what they're trying to say. Okay.
Okay.
All right. Thank you so much. So as I was saying there, what we want to do is, so on this rack, on the spice rack, we have 4 green, 2 blue, and 2 orange, maybe bottles of spice, right? Now, here's my question. How many ways can the spices be arranged if all spices of the same color must be together? Let me actually just paste my question there. Okay. Can we all see that question? Please confirm if you can see that.
Yes, I can.
All right, perfect. Thank you so much. So here's the question. How many ways can the spices be arranged if all spices of the same color must be together? So what we know is we have 4 green, right? If we have 4 green, I'm going to say this is 4 factorial, right? There's 4 ways in which we can. Then 3 blue, that'll just be 3 factorial. And then 2 orange, that'll have to be 2 factorial. Okay, and what are we going to do? We're going to just multiply that together. But we're not done there. Why are we not done? Because of the order. What order am I talking about? We can start with orange. Remember, in this case, we have green, blue, and orange. We can decide to start with orange, then followed by blue, then green at the end. Or we can start with blue, with green in the middle. Right? And that will be 3 factorial. So the 3 factorial, this 3 factorial is accounting for the green, blue, and orange. So green, blue, and orange. We can decide to start in whatever order that we like. Hence, our final answer is going to be 3 factorial multiplied by 4 factorial multiplied by 3 factorial multiplied by 2 factorial. Six times 24 times 6 times 2. So times 2. That's 2 factorial. And then calculator work. That should give you 172. Hoping I didn't make a calculator mistake. I think we're fine, but if you can spot a mistake, please do let me know. I think we're fine so far. Yes, okay. Rohot's also got the same answer as me, which is fine. I'm hoping we're all together there. Okay. Let's move on to the past paper questions. Please make sure that you're not left behind. If you have any sort of question, make sure that you do ask. So here's a question. A survey was conducted among 100 boys and 60 girls to determine how many of them watched, how many of them watched TV in the period during which examinations were written. It's a very bad thing to do. Can't afford to watch TV there. Their responses are shown in the partially completed table below. Calculate the values of A and B. Okay, that would be quite easy. We know that these two must add up to 32. So I can immediately say A plus 12 is equal to 32. Then A must give us 20 if we subtract 12 from both sides. Let me just write it there in case I need it later. Now, for B, we're going to do more or less the same thing. So we know we can say B is equal to 80 plus 48. And that gives you 128. Hoping we're together there. Okay, Rohotse got 96. Rohotse, I'm not sure your 96 where it's coming from. But if we're looking at B, right, it's the total. So you watch TV during examination. So it must be this plus that, which will give us B. And we simply add the two, which must give you 128. Okay. Now moving along. Are the events being male and did not watch TV during exams mutually exclusive? Give a reason for your answer. I spoke about mutually exclusive, right? And what did I say about mutually exclusive? Like they cannot happen at the same time, right? Now, let's check. Male and did not watch TV. So this would be no. Why is it a no? Let's check. The probability of being male and not watching TV is equal to what? 20 over 160. That's the total, right? Which is not equal to 0. I'm hoping that's clear. I'm going to quickly move on. There are no questions. If a learner who participated in the survey is chosen at random, what is the probability that the learner watched TV in the period during which the examinations were written? Okay, so let's try to find that. So the probability of watching, so the probability of watching TV, let me just say WTV, is equal to 128. Let's go back. Divided by the total, which is 160. Okay, if you simplify that, you should be getting 4 over 5, and finally you should be getting 0, 0.8 or 80%. Now, the last question. If a learner who participated in the survey is chosen at random, what's the probability that the learner is not a male and did not watch TV in the period during which examinations were written? Okay, let me just highlight that. Not male and what? And did not watch. Let's try to analyze that. So this means if it's not a male, it's a female in this case, right? So the probability of female, right, and not watching TV. Make sure that you understand that part. It's not male, that has to be female and did not watch TV. That's what we want. So going back to our table, female and did not watch, that'll be 12. Over a total of 160, which is 3 over 40. Yes, 3 over 40, and that would simplify to 7.5%. Okay, no questions. I think everyone is with me. Let's look at this one. The digits 1 to 7 I used to create a 4-digit code to enter a locked room. How many different codes are possible if the digits may not be repeated? Very important. Let me just highlight that. So it's a 4-digit code. Digits may not be repeated. The code must be an even number, bigger than 5,000.
It's a point.
My apologies there, I got disconnected. I'm hoping that you guys can hear me now.
Yes, we
Can you
can.
please confirm if you can hear me? Okay, sorry about that. My network is misbehaving. It kicked me out. Let me share my screen again.
And before you proceed there, there's a question. It says, if I say one, not male and not watching TV, will I get the same answer?
If I said one, is it in the chat or is it on TikTok?
From TikTok.
Can you please repeat the question for me?
If I say one,
Yo, can you please repeat the question for me?
yes, can you hear me?
Yes, I can hear you.
Yeah, it says, if I say one, not male and not watching TV, will I get the same answer?
Say one, not male, not
watching TV.
I'm trying to understand the question. It's not the one part I'm not getting fully. I think they're saying one minus.
Yes. So it's one minus in bracket, not male and not watching TV.
One minus in bracket, so not male and watching TV. Okay, so they took the complement. Complement should work perfect. That should definitely give you the same answer.
Okay.
Yes, sorry, I wasn't understanding that. Okay, so we were here. We were trying to create a 4-digit code. So the code must be an even number. Right? So if the code is an even number, I know I have to end it with either a 2, a 4, or a 6. 1, 2, 3, 4, 5, 6, 7. That's for the code to be an even number. Now, if we have that, okay, let's look at the first digit. We want a code to be greater than 5,000. Okay? So if we want it to be greater than 5,000, we have how many numbers that we can put? 1, 2, 3. Remember, if we put a 5 there and we put maybe a 2 at the end, we still have something that is bigger than 5,000. Okay. Now, if we put a 5 there, we have bigger than 5. So how many options do we have of numbers? We have 5, 5, 6, 7. Now, it means we have 3 options there. Okay, so if we have 3 options there, now let's think about the middle part. So the middle part now, let's say we used, let's say we used 5, and then these 2 are out. Okay, I'm going to consider a case where I'm ending with a 2. So if I'm ending with a 2, the 2 is out. Right? But I had 3 options here. So I could have put the 3 numbers there. Now for 5, how many options do I have? 3 options. Okay, but now let's then look at it this way. So now I'm going to go from right to left to say I've used the 5. Then I can put any number because it will be greater than 5,000. So 1. If I've used the 2 is out. They say they can be did not speak about, oh no, yeah, can't repeat. So that is out, then can definitely go to a 3. I don't know if we're together there. Right. The easiest way I can go about such a question is I'm going to say, for the first option, I have 3 multiplied by 5, then multiplied. So if I say it's 1, 2, 3, multiplied by 5, then multiplied by 4, multiplied by 1. Right? It means that here I have 60 options for position number 1. Okay. Now, for position number 2 as well, how many options? I have 3 multiplied by 5, multiplied by 4, multiplied by 1, which means that I have 60 there as well that I can add this option. Now, for position 3, okay, how many do I have? I have 2 times 5 times 4 times 1, which means I have 14. Making my total 160. There are no questions so far. Okay. Moving along. A survey was conducted among 100 teenagers and 60 parents to determine how many of them watch TV over weekends. Their responses are shown in the partially completed. Okay, so this is the same as the one that we just did. It's just that we changed the ones that one. Yes.
The question just came in now. They're asking for you to repeat.
Okay, I'm gonna repeat. I think I'm gonna have 5 minutes at the end. I still have quite a lot of questions that I haven't done. So I'm going to just make a note to repeat in the last 5 minutes because I'm seeing that I haven't done a lot of questions, but I'm gonna come back to it in the last 5 minutes. Okay. Please carry on. So A and B are 2 events in the sample space. Probability of A is equal to 0.3 and probability of not B is equal to 0.8. Determine the probability of A and B if A and B are independent events. Okay. So this is very important, not being. Okay. Now, how can we go about such? We know that the probability of B is equal to 1 minus 0.8. Okay, and that is simply going to simplify to 0.2. Now, probability of A and B, what would that be? That would simply be 0.3 multiplied by 0.2. Hoping we're together there. And then that should give you 0.06. Hoping we're together. Now, next question. Determine the probability of A or B if A and B are mutually exclusive events. So the probability of A or B is equal to the probability of A plus probability of B. What did we say is the probability of A? That must be 0.3. We did find the probability of B. Remember, these are mutually exclusive. Probability of B was 0.2. And this is 0.5. Now, looking at B, there are 12 chocolates which all look identical, right? In a box, so 4 of the chocolates have mint centers, 4 have caramel centers, and the last 4 have strawberry centers. Ali randomly selects 2 chocolates and eats them. Determine the probability that the 2 chocolates eaten will have different centers. All right. Now, what we're going to do is I'm going to try and find the probability of the same center, right? So I want to do this. I want to say 1 minus the probability of the same center. And if I do that, I'm going to have 1 minus. So we have 4 of the chocolates have mint. So it must be 4 out of 12, then multiplied by 3 out of 11. Because if you take, so for the first option, 4 out of 12, and then the next option, you've decreased the number of chocolates. Okay. Then from there onwards, just plug that into your calculator. Right. Alternatively, what you could have said is you have 4 out of 12 multiplied by 8 out of 11. Then you multiply by so 4, then it's 4. I have to multiply by 3 here. My mistake. I have to multiply by 3. Multiply by 3. This is just an alternative method, depending on which method that you're comfortable with.
It's about
Yes, dear.
Mahoso from TikTok says, I think tree diagram will help us to find that probability. Is that correct?
You can rely on a tree. You can use a tree diagram. That's perfectly fine. You can definitely use a tree diagram. Okay, I will do some questions with tree diagrams shortly. If that one will help you with tree diagram, you feel like it's much easier for you to do there. That's perfectly fine. And use the tree diagram, get all the marks. It's much easier for some people to see, so definitely can use the tree diagram. Now, next question. Given the digits 3, 4, 5, 6, 7, 8, and 9, calculate how many unique 5-digit codes can be formed using the digits above if the digits may be repeated. So 1, 2, 3, 4, 5. If it's 5, then we know how many options. So 1, 2, 3, 4, 5, 6, 7 options. We can repeat. Then that is just 7 to the power of 5. And that should give you 16,807. Now, the digits may not be repeated for the next question. The digits may not be repeated, and it's simple: 7, 6, 5, 4, and 3. Are we together there? Okay. Just multiply and find your answer. Now, 11.2. How many unique 3-digit codes can be formed using the above digits if digits may be repeated? Okay. So 3-digit, we have 3 slots. Digits may be repeated. The code is greater than 400 but less than 600. The code is divisible by 5. So if it's divisible by 5, it must end with a 5. That's the only way it's divisible by 5. Now the code is greater than 400 but less than 600. So meaning that it can be the 4 here or the 5. So we have 2 options here. And then in between, we have 7 numbers because digits can be repeated. Let me just multiply. Right, but here's my mistake. I'm seeing my mistake. So this 5, I cannot write a 5. How many 5s do I have? Only 1 5. Sorry for that silly mistake. Not a 5 there, but there's only 1 5 that I can. Then my answer must be 14. We're going together there. Now, it's a different question altogether.
It's about
Yes, dear.
Mahoso from TikTok is asking, This includes multiplication between numbers to show you are multiplying. And
Okay.
then they say it's 11.2 2 times 7 times 1. I see
That
you
is
fixed
correct.
it there.
Yes,
Okay.
I did. Yes, thank you, Theo. Okay, now the next question, 12.1. Given the probability of A is equal to 0.45, yes, Theo?
Before you proceed there, Dale is asking, so say, if they say the number is divisible by 2 or any other number, we should write that number at the end.
Not that number, but the number of ways. So if, let's say they're saying our number that we're looking at is divisible by 2, we want options here. So at the end, we want options for our number to be divisible by 2. Because not only 2, if it's a 4, if it's a 6, if it's a 8, if it's an even number, if it's a 0, those are divisible by 2. Right? So if they, in this case, if they had said that it is divisible by 2, what we were going to do is we're going to look at the options for it to be divisible by 2. It's 1, 2, and 3. That's what we're going to put there. There are 3 options for a number to be divisible by 2. Okay.
Okay.
Let's look.
And
Thank you.
there's another one here. Hey, Stephen, can you hear me?
Yes, I can hear you. You can go ahead.
So 11.2, Mahoso says 2 times 7 times 1. And Mklima, I hope I didn't butcher their name. What if the last digit is 0?
If the last digit is 0, it's perfectly fine. It's just that 0 is not an option in this case. Right? So here we can't have, so like, this question needs to be a little bit, or their question needs to be a little bit more explained, because I don't know what they actually mean by the last digit being 0. What's the case there? So if we want the last digit to be 0, and 0 was an option, was one of the digits that we give there, right? We have only one way to put a 0. So we're just going to write one option for 0, if that's what they were looking for.
Okay, thank you.
Thank you, Theo. Okay, now let's check here. So we have the probability of A, B, and probability of A or B. They're given, right? They're saying determine the values of Y if A and B are mutually exclusive. So because they are mutually exclusive, so I'm going to go about it. Second, let's say the probability of A or B is equal to the probability of A plus probability of B. Okay, we know, and they're mutually exclusive. That's why we don't consider the other part. That's what I explained at the beginning. Now, A or B is given to be 0.74, 0.45, then plus 1. Y equals to 0.29. Okay. Now, 1.2. So, an organization decided to distribute gift bags of sweets to a grade R class at a certain school. There is a missed gift in exactly 1/4 of the total number of bags. Each learner in the class may randomly select 2 gift bags of sweets, one after the other. One after the other. The probability that a learner selects 2 bags of sweets with a mystery gift is 7/118. Calculate the number of bags of sweets with a mystery gift inside. Okay. So what I'm going to definitely do here is to rely on a tree diagram. I won't be able to do this one without a tree diagram. So let's check. All right, so the first case, let's look at it this way. Right, I'm gonna put it back here, and then we'll have a suit. Okay, now for the gift, we're gonna say it's x over 4x. And for the suite, it will be 3 x over 4x. Now, it's one after the other. We're going to have the same thing, sweets and gifts there. So then another tree, another branch here, where we have sweets and gifts. So here we have x minus 1 over 4x minus 1. Right. So the definition, all I did is I said, let mystery gift bags equal to x and total number of bags equals to 4x. Right. Now, if that's the case, please make sure that you're with me before we carry on. Don't wait to say you're confused at the end. So if this is the case, then what we can do is we can say x over 4x multiplied by x minus 1 over 4x minus 1 is equal to 7/118. Then it's just a matter of simplifying here. 1 over 4 multiplied by x minus 1 over 4x minus 1 equals to 7/1. 118 x minus 118 equals to 112 x minus 28. Just simplify. So further, going to have x equals to 15. One. So I can still have time to do the question that I said I'll go back to it to you and forgotten about it. Let's look at this one. Machine A and machine B are 2 different coin pressing machines that operate at the same time. The probability that machine A only presses a 5 rand coin is x, and the probability that machine B only presses a 5 rand coin is 0.3. The probability that both the machines press 5 rand coins at the same time is 0.1. If A and B are independent events, determine the values of x and y. Okay. So for independent events, remember that the probability of A multiplied by the probability of B equals the probability of A and B for independent events. Okay, now that's what I'm going to use and apply here. So the probability of A is x plus 0,1 multiplied by the probability of B, which is 0,4 because we added the two together. This must be equal to 0. So x plus 0,1 is equal to 0,25 because we divided both sides by 0,4. And x would simply be 0,15. Okay. Now, we're not done. We found x. We need to find y. So I'm going to say x plus 0,1 plus 0,3 plus y equals to 1. The entire sample space must be 1, never more than 1. Now it's just a matter, excuse me, it's just a matter of substituting. 0,15 plus 0,1 plus 0,3 plus y equals to 1. And y should give us 0,5. So, okay. Okay, now the last question, 11.1.2, under that one. Determine the probability exactly one of the machines expressing a 5 rand coin. So exactly one of the machines is expressing a 5 rand coin. Okay. So exactly one that would simply be it's either we are in this region here or that one there, not both. And that would simply be 0,15 plus 0,3, which should give you 0,45, because we don't want the intersection. I'm hoping we're together there. Okay, moving along. Wilson takes a driver's test, right? The probability that he will succeed on his first attempt is 3/7. For each attempt that he redoes the test, the probability of passing the test increases to 3/100. What is the probability that Wilson will succeed after 2 attempts? Okay, so we have, I'm going to do a tree diagram for this one. So I'm going to have passing day and failing day. right? So they say the probability that he will succeed in passing, that is 3/7. So the possibility of him failing would simply be 4/7. I'm hoping we're together there. Now, the next branch, they said for each attempt that he does, the probability of passing, so I have passing here, increases to 3/5. So 3/5 here, then I'm going to have 2/5 there. Then we'll have another branch there where passing is still 3/5. What is it that we're looking for? We're looking for him succeeding after 2 attempts. And that means it's going to be this order here. That is going to be 4/7 multiplied by 3/5. That's just 12/35. No questions, I'm going to carry on. Determine the probability that Wilson will succeed after 3 attempts. So if it's succeeding after 3 attempts, it means that it's a failure, pass. In the previous question, it was just a failure followed by pass. Hope you can see the order there. Now, that would simply be this region here, of that manner. Then that will be 4/7 multiplied by 2/5 multiplied by 3/5. It's going to be 24/175. Open it all together there. Okay, no. All right. Then I'm going to go back to the question that I said I'm going to leave for the very end. Let's need to repeat it. Just copy it and then paste it. So please try to pay extra attention. I'm going to be quite slow explaining this one so that you understand what it is that we're doing exactly. So the code must be greater than 5,000. Right? What does that mean? That simply means that the first number must either be 5, 6, or 7. Please make sure you understand that part. Now, I'm seeing questions in the chat. Which part do you want me to repeat? I'm not too sure. which part you want me to repeat. Okay, because I've already, okay, let me just go back to it. 11.2. So the last question that I was doing here, the probability that Wilson will succeed after 3 attempts. I'm hoping it's that one. So him succeeding after 3 attempts, like I was saying there, that it will be what? Failure, failure, pass, because he must succeed after 3 attempts. So on the 3rd attempt, that's when he needs to succeed. Right? And we know that the first failure is 4/7 as per our tree diagram. The second failure is 2/5 as per our tree diagram, then followed by a pass, which is finally 3/5. Then all we do is we just multiply 4 times 2 times 3, 24, then 7 times 5 times 5 gives you 175. If that's not the question you want me to repeat, you will type it in the chat. Okay, otherwise I'm going to carry on with this one. Now, the code must be an even number. So if it's an even number, it must, so last digit or last number, last would be 2, 4, or 6. Okay, now we're going to break it down to the first case being the number 5. So if the first case is the number 5, I want you to follow completely every step. Case 1, first digit equals to 5, then it simply means we are going to have, so we only have 1 5 in the beginning because we said the first digit is a 5, right? Then at the end, how many choices do we have? We still have 3 choices. Now in the middle, how many options do we have? We're going to have 5. Remember here it's 1 because we want a 5. This is the case where the first digit is a 5. How many ways can you put a 5 there? Only one way. Now here we have 5 multiplied by 4. Right. Now how many options do we have there? That is 16. Please make sure that you understand that part. If you have questions, please ask them now because it's going to get more. There's more work. So I'm going to say case 2, first digit is 6. Where am I getting these digits? This is the number being greater than 5,000. I can only put a 6 there, in the first position. Then here I'm still going to have 5, 4, and 3 at the end. And a 1 here. This should also give you 16. Now let's look at the last case. First digit is 7. One of the 7, then we have, so we have 3 choices here. We still have 5 and 4 and 1. And what does that give you? It also gives you 16. Okay, now there's one thing that we are forgetting. Remember that the two middle digits can be arranged in, so I'm not done here. Write it here. Arrangement of two middle digits. We have 5 and 4 options, right? But we can arrange it the other way around. So I'm going to multiply by 2. 5 and 4, or 4 and 5. That's why I'm multiplying by this 2. Right? And what is that? That is going to be 14. Now all we do is we sum up everything. Right. Now what we're going to do is, so it's 16 when the first digit is 5. Then, sorry, I'm actually messing this up. So this is case 2. The first digit is 6. I don't have 3 here because the first, so let's look at case 2, making a silly mistake. If we look at case 2, I took a 6 in front, right? Then it means that at the end, I don't have 3 options because remember, for it to be an even number can end in 2, 4, or 6. But because I used the 6, it means that I have only 2. Okay, that has to change there. If that's the case, then we're going to have 30, and the first digit is 6. Then plus 60, when the first digit is 7. Then the total should give you 160. It is a bit of a high order question, which can be a little bit difficult. So I'm urging you to maybe just apply your mind, look at it again, and go step by step, break it down into the cases I have broken it down into on the screen, and check if you get the same answer. I think that will be the easiest way to go about it. Okay, I'm not seeing any questions in the chat. Theo, on your side, on TikTok, are there any questions?
There was one question from Bonolo. I just pasted it now on the chat. I don't know if you can understand that.
Okay. So PIN is made up of 5 digits chosen from 0 to 9. What is the probability that the PIN will at least contain 9? Okay.
So those are two chats. I just combined them. So the 1971 is the follow-up to that one.
Okay. I'm just trying to understand if they by any chance mentioned any repetition. Was it on TikTok?
Yes, it was on TikTok from Bonolo.
Okay. Okay, so I'm gonna do it this way. It's made up of 5 digits, 1, 2, 3, 4, and 5. I'm going to assume there is repetition. Then we have 10, 10, 10, and 10, and 10, because it's from 0 all the way until 9, 10 digits. Right, now this is going to be 100,000. It's 10 with 5 zeros, well, 1 with 5 zeros rather. So then what I'm going to do next, I'm going to calculate the number of digits that do not contain any 9. Right? So if that's the case, so do not contain any 9. So if they do not contain any 9, it simply means that each digit, it can now be one of the 9 remaining digits between 0 and 8. So from 0 all the way to 8, because we've taken out a 9. Okay, which means we have 9 to the power 5, because we still have five slots and 9 digits to pick from. Right? That should give you 59,049. Okay, so the probability that it doesn't contain any 9s, so probability that it doesn't contain any 9, prob of no 9 would be equal to 59049 all over 100,000. Okay, now the probability that the pin contains at least 1 9 should simply be of at least 1 9. That should simply be 1 minus the probability of no 9, which is 1 minus 59,049, 100,000. And that should give you 0.40951. And that's how you would do such a question. Okay. All right, guys, it is now 3 minutes after 8 o'clock. I'm not seeing any more questions in the chat. And I think we can adjourn here for today. So please make sure that in your own time, you do revisit the recordings or some of the problems that you've been looking at, so that you fully understand this section or the sections that we have covered. Then I think we can all end the day for today. We'll definitely see you tomorrow for physical sciences. Mr. Rangata will be taking you through that section. Please make sure that you connect tomorrow as well. All right, Theo, I think if you are ready, you can take us away with the awesome outro on your side.
Okay, thank you. Just ending this.
Thank you.